Alright, so. At 21, we're doing. 5.5, which is on counting techniques. When we shuffle a deck of cards, it changes the order. Or it changes the arrangement of the cards in the deck. How many different ways can they be arranged? This is kind of like how we started the pocket cards the other day. There's 52 options for the first card. The second card, there's only 51 cards left. It could be one of 51 different cards. We're not doing probability though, we're just looking at the number of ways it can be arranged, so we don't need the numbers on top. Next card could be 50. Next card could be 49. And we can go all the way down through the deck to 5, 4, 3, 2. And the final card doesn't have a choice, there's only one card left. How long do you think that would take you to enter in a calculator to find out? That's a lot of time to type. We have a notation for this. Let's introduce n factorial. And I think the easiest way to introduce the factorial is to show you what this one is in factorial. This is 52 factorial. So the factorial symbol, when it's got the exclamation mark, when it's got a number in front of it in math, just means keep multiplying it by itself, but reduce by 1 until you get down to 1. So if I had 5 factorial, this would be 5 times 4 times 3 times 2 times 1. That's 120. Now, this comes up often enough that it's on damn near every calculator except basic calculators. On a calculator, there's a couple ways to see it. Mine shows up right here as x factorial. It's above my key, so I have to hit shift and hit the button when I use it, but it's. I don't know if I can get that closer. X factorial is right there. So you might see a button that has x factorial, or you might see n factorial. Sometimes they have n factorial. Some calculators have a button that says PRB. And when you hit the PRB button, you're given 3 options: n factorial, NCR, and NPR. If you have your calculator with you and can't find it, ask me after class. If you can find it. Plug in 5 factorial and make sure you get 120. Usually it's you hit the factorial after the number. Like when I do it, if I hit 5 and then shift factorial. I actually chose 5 exclamation point. You should get 120. And then once you've done that, do 52 factorial. Let's look at how many ways we can arrange a deck of cards. .066. And mine has a little. How can I make it show up? Times 10 with the 67. Which means. After I deduct the 3 from that. I have 800 or 8066. And then 64 more zeros. We were just talking about this in math 321. To put this in perspective. Light travels. I got it written down over here. $5.88 trillion miles in a year. Light is the fastest thing possible. It only travels 5.88 trillion miles in a year. How many zeros is that? That would be in the millions category. This is the billions category. Trillions would be right here, which would make these two an 8. That's miles in a year. Not in an hour, in a goddamn year. And it's only got. If I wrote it in scientific notation, times 10 to the 12. That's how many different ways you can juggle a deck of cards. It's fucking a mind-staggering amount. Make sense? That's how we use the factorial button. This is what it's good for. It's good for counting different possible combinations. So the factorial key is great for counting different combinations. I'm gonna quickly revisit that topic we had last Tuesday. And we're only gonna do, remember when we talked about, we had 8 guys and 5 gals, that problem? We did at least 1 girl. Let's just look at the ways we can pick 4 people in general. Like we put everybody's name in a hat and drew out of a hat. Well, there's 13 people, the first person we selected, Dave. And after that, there's only 12 slips of paper in the hat. So there's, the second person can be one of 12. The third person can be one of 11. And the fourth person can be one of 10. That's what we want. If we had the factorial, if we use the factorial key though. We would have a 9, an 8, a 7, a 6, a 5, a 4, a 3, a 2, and a 1 if we used 13 factorial. What can I do to make it so I only got these? And still use the factorial key? Well, if we divide it out. 9 times 8 times 7 times 6 times 5. I have 5 listed there twice. Let's just learn to fucking count downwards, Dave. I could divide that out and these would cancel out, the 9s would cancel. Those would cancel, 8s would cancel, 7s, 6s, 5s, 4s, 3s, 2s. 1s, basically. What is this number on bottom in terms of factorial? Anybody know what it is? No. Factorial is when you're multiplying all the numbers up to a certain number, it's that factorial. Just like 52 was 1 to 52 multiplied together. This is 1 to 9 multiplied together, it's a factorial of 9. So if you wanted to do this in a calculator, you could do 13 factorial divided by 9 factorial. And I'm gonna get 1,000 or 17,160. Or I could, if I wanted to take the time, do 13 times 12 times 11 times 10. I get the same back. As you can see there where I multiplied. Now, in this case, I think it might have been just as fast to do the 13 times 12 times 11 times 10. But in some cases, it's much easier to do this factoring, factorial and canceling out. And this leads us to our next topic in this section, which is. Well, it's kind of 2 topics. And we're gonna discuss what's the differences. Permutations versus combinations. This goes with the NPR button on your calculator, and this goes with the NCR calculator button. Where N is the number of distinct or individual objects that you can tell the difference between. And R is the number that you're selecting. So we need to describe what the difference is here. Combinations is probably the easiest one to describe. Combinations is like a combination pizza. You have n toppings to choose from. You want R of them on your pizza. Let's pick 3 toppings. What's someone's favorite topping? I was hoping that was the first one. What about another topping?
Bacon,
And another?
Meat lovers.
Sausage then. You're putting together the pizza, does it matter if you put the pepperoni down first? The bacon and the sausage? Does it matter the final outcome of the pizza? Not really. The order that we put them on the pizza doesn't really matter. Especially if you use like the diced pepperoni rather than the big flat discs. Like big fat discs, if you try to set that on top of a piece of sausage, it's not gonna stick to the cheese. But if you have like little diced pepperoni. So combinations, order doesn't matter. Permutations, it does. This is like when you're selecting first place, second place, third place. You just had the Summer Olympics, the gold, silver, and bronze. Which is funny, because a good bronze really looks goldish. It looks more like gold than that's what they always depict bronze as. It could be something like president, vice president. You're drawing from or picking people from a club. And you need people to fill the slots. Like, let's say we were doing our 8 guys and 5 gals. And we wanted a president, vice president, treasurer, secretary. Back to our guys and gals. And we pick 4 people for the task. For the officers. Order here matters, if you're selecting them in an order, pick the president. You can't, the vice president can't be the president. Because that would be 2 roles. This is the permutations or order matters. It's the NPR key. And there are 13 people to choose from, and we're picking 4. Mine, I have an NCR key right here. And right above it is the NPR option. So if I do 13 shift NPR, it shows up as a P there, and 4. I'm gonna get 17,160. But we already saw how that's set up. 13P4 is apparently the same thing as 13 factorial over n factorial, or 9 factorial. Because that's what we got earlier. And the way you get this formula wise. NPR. Not National Public Radio or anything like that. NPR is n factorial over n minus r factorial. So in our case, we had 13 factorial over 13 minus 4 factorial. So, story example, when I was a kid, I'm guessing it was around 10 or 11. My brother is less than 1 year younger than me, so for like 2 weeks, we had the same age. We lived in Sacramento, the state fair is there, and our friend that lived down the street, his stepdad fed the horses at Cal Expo where the state fair is held. And so every time the state fair was around, it was always in the middle of summer, he would get us into the fair by going to the racetrack where the horses are. And so my mom gave my cousin like $20 for each of us to spend there. This was back, and I'm going with like 1985 or so. $20 went a lot further than it does today, but it still probably wasn't a lot. And we go through the racetrack, and of course, me and my brother are curious about it. So my cousin says, all right, I'm gonna show you how betting works. You'll bet on one race and you're gonna bet on a trifecta. So the trifecta in horse racing. Is pick first, second, third in order. Not the top 3 horses that place, but what order they placed in. Now, generally, they have 12 horses on the track. Her idea was to cost us $2, eat up some time, get the ticket, go watch the horses run. And teach us a lesson that gambling makes you lose money. I get what she was trying to do as an adult. I don't know anything about horses. But I picked 3 names, the names I liked. And David won. David won his first trifecta. Did that bitch give me the money from the winning ticket?
No.
Hell no, she didn't. That was the opposite of the goddamn lecture. I assume. And this is what she said, I'm gonna go give it, we're gonna give it to your mom when we get home. I assume she did, but I don't know, and both of them are passed away, and I never asked before. They both passed away, so I don't know, all I know is I was out $2. And I should have had a lot of money. Cause when you bet on the trifecta, they pay you good odds. Why? It's hard to win. How many different ways can 3 horses place? Can we pick 3 horses out of 12? We're choosing from 12, that's the total number of options. We're selecting 3 of the horses. Order matters, so we're doing 12P3. As a reminder, this is 12 factorial over 12 minus 3 factorial. And if I cancel things out. Factorial wise. This is just 12 times 11 times 10. Which is 1,320. 1,320 ways those horses could have. Ran with were the top 3 what they were. So the probability of winning that trifecta. You had to pick the single combination that was correct. 1 out of 1,320. Arrow point. Let's see, it's got 10 to the -4, which means 300. 757 and. It kind of keeps repeating, I'll do that. If I were to write this as a decimal or a percentage. 0.076%. Not even 0.1%. Not very high. You can imagine I was mad as fuck for the rest, I'm sure I threw a good tantrums the rest of the day. And that's what she fucking gets. She could have at least lied and said you won this amount and given me a little extra. Like I said, oh, it was $10. It wouldn't have worked on me because I liked math at that age and I knew how to fucking multiply. I knew how to multiply by then. It was like a $2 ticket. I forget what the odds were. I'm sure I won at least $100. I don't remember what it was though. Combinations. In combinations, order doesn't matter. And how does it change our formula? NCR is a lot like NPR. We have n factorial. We have n minus r factorial on bottom. But we also have r factorial. So this is where order doesn't matter. If we just wanted the top 3 horses. Or in the case where we were picking 4 people at random. And the order didn't matter. Like let's say you were all winning, like winning a prize. And you didn't care if you were the first person selected or the last person selected. As long as you got the prize. We use that. And of course, it's the key on the calculator. A good example of this is winning the lotto. So Mega Millions. Maybe I need another piece of paper. We're at the end of that piece. So. Does anyone need that longer? Just wanna make sure. What is the probability of winning the Mega Millions? So if you've never played the Mega Millions. It's a $2 ticket. You pick 5 balls out of 70. Or numbers. You're actually picking numbers, but they use the balls to. Randomize it. And you pick one number out of 25, that's the mega number. Your order does not need to match the order the ball come out in. In fact, usually when you, if you get a ticket. No matter what order you like filled in the bubbles, they put them out in numerical order. They're always in numerical order. Cause it's easier to check your ticket right away to see if you won, if it's in numerical order. So, how many combinations of tickets are there? Or how many ways can we select? Five numbers out of 70 and 1 out of 25. Since order doesn't matter, we can use NCR. So for the 5 out of 70. This will be 70. C5. This one will be 25. C1. And since they're all affecting each other, they're multiplied together. So 72 C5 times 25 C1. If you're only selecting one, you really don't need NCR for selecting one. If I can only select one ball and there's 25 balls, how many ways could that turn out? Just reasonably. There was 25 different numbers and I could only randomly pick one. How many different options do I have? 25. In fact, NC1 is always just N. So 70 C5 times 25. I am getting, when I multiply that out. 302,575,000. 350 ways. This is basically ways to buy a ticket. Now tickets are $2 each. So if I wanted to guarantee I won. I'd have to buy each combination. Which is $605 million. And some change. Oops. 150,700. Let me load up the Mega Millions site and show you what they tell us. How many different ways can I win before I do that? How many ways can I win? If there's 302 million tickets, how many ways are a winning ticket? For the top prize? There's one, right? So the probability of winning the Mega Millions. Is 1/302,575,350. When they talk about odds, and they do this in gambling, off and all the gambling things. This is written as 1 in 302 million. I'm just gonna show it to you on the computer real quick. Mega Millions website, how to play. Jackpot, 1 in 302,575,350. If you divide by 25, you should be getting that. So we're not doing the mega ball there. Let's change the recording back to document camera. There we go. So. If the jackpot is above. I can spell jackpot right. Is greater than that 605 million. And you had some way of buying 302 million tickets in like fucking 3 days. Cause they're not a week apart, there's like 2 drawings a week or some shit like that. You can guarantee a win. Now, I don't think one person could feasibly do it. I know you couldn't do it at one machine, no matter how quickly you fucking scan them. You would have to like have a lot of people doing this. So you probably want the prize bigger. But even if it was only like 1 million bigger, you're paying people to buy tickets for 3 days. You give them each 20,000 to buy as many fucking tickets as they could and give them all the. Give them specific combinations to pick. You could win, force a win. If you were a fucking trillionaire. Cause this is only millions. I probably wouldn't do this if I had billions. But if I was a trillionaire where this was chump change. Cause it's trillion, fucking this is like pennies when you're talking about $10,000. I'd probably do it just so that I could say I won the Mega Millions. I fucking. Have that, I have it all ready ahead of time. Have all the little sheets filled out. Make sure they were done and then pay somebody, like pay a bunch of people to do it, so I can guarantee win. So we have this NCR. And this is frequently read as N choose R. Let's go back and take a look at the 8 guys, 5 girls again, and now let's go with our original question. What was our original question with the 8 guys, 5 girls? If we pick 4 people. What is the probability? At least one is a girl. Again. If you identify as non-binary or this, even if you don't, and this is an important matter to you. Just work with me. I can't have 15 million categories with the spectrum of gender identity. Just doesn't work for doing statistics. We ended up saying it was 1 minus the probability of all boys. By using the complement rule. And that was, what did we have? 1 minus 8 over 13 times 7 over 12 times 6 over 11 times 5 over 10, I think is how we did it. There's a way of doing this with what we've been doing today. The alternative is we could do 1 minus. There was 8 guys and we're choosing 4 of them. Out of 13 people, choose 4. And what do we get when we had it? I got it open here. We ended up getting 0.902. Let's do that here with our choice method. I've got 1 minus 8 choose 4 divided by 13 choose 4. Look at that. Quickly. Quick calculator problem. You just have to know how to enter it. Every once in a while, I gotta look and see if this version has it. In the review homework, they often do this with poker cards. Counting ways to get 3 aces out of the deck. Or what doing the probability and you would do the 4, choose 3. I'll look it up and get back to you on that. There's one more topic in this category. And that is when the objects are not distinct. Non-distinct objects. Like when you can't tell the difference between them. When you're dealing with people, it's fairly easy. Let's see, I've got blue, red, and green pins. Let's say we've got 10 flags. And 5 are green. Three blue. And 2 red. And we have 10 slots for flags in a line. How many different ways can we arrange the flags? Okay, so I'm gonna show you how you can reason through it, because you're probably not gonna remember this. But hopefully you'll remember the permutations and combinations, what they mean, please. Let's just place 5 green flags. Let's just pick 5. I'll put one there. I'll put one over here. Maybe there's the last 2 are both green. And maybe the second one was green. For the green flags, we had 10 slots to choose from. We picked 5. Ten, choose 5. Then we do our 3 blue flags. We've got 5 slots to choose from. And we pick 3. Because we've got 3 flags. And let's just say by random chance, we get the 3 that are right next to each other. I'm just filling them in. This would be 5, choose 3. Red flags. We have 2 slots. And 2 flags. Do we get a choice? Not really. It doesn't matter which one I put because they look the same. 2 choose 2 actually equals 1. But I'm going to show you how this works out. And we're going to use the formula version. So remember that NCR is n factorial over n minus r factorial times r factorial. The green one is 10 factorial. And we do 10 minus 5 for n minus r, gives us a 5 factorial for n minus r. And r was also 5, so we have 2 factorials like that on bottom. The blue ones, we had 5 choose 3. So n is 5, it goes on top. 5 minus 3 is 2, so we have 2 factorial there. And then we had r, so 3 factorial. And I'm gonna put in the 2 because it illustrates one more thing I needed to show, and I didn't show it earlier. N was 2. N minus r is 2 minus 2 is 0. That should be a 0 factorial and then a 2 factorial. What I didn't tell you earlier, and I should have. 0 factorial is defined to equal 1. We define it this way for this type of problem. Because of n choose r. We need it. We can end up with a 0 factorial in these problems and we need something. Can't just be divided by 0 because we know dividing by 0 is bad. Y'all with me here? Okay, rather than crossing them off, because I'm gonna scan this, I'm gonna circle the ones that cancel from top and bottom. But numbers on top and bottom, I can cancel. I have a 5 factorial here, and that can cancel that factorial there. I have a 2 factorial here, and I'll cancel this one right here. Remember, when we cancel, they're replaced with ones. And that kind of shows you that this 2 choose 2 equaled 1, because there's only ones in that right fraction now. You know what, better yet? I'm gonna choose that 2 factorial. So that I have 10 factorial on top. On bottom, I have my green 5 factorial. I have my blue 3 factorial. And I have my red 2 factorial. This is how you do n distinct objects. It's the total factorial. Total of all factorial. Over the amount in group A factorial. B factorial. And I'm gonna say up to k factorial. For k groups. And those things are the amount in each group. Now, what does this end up being? I have no idea. It's like 2,520. Not 2,520. Yeah, again, make sure I said the right thing. Yeah, 2,520. I don't know why I had a bucket factorial there. Apparently, there's 2,520 ways to place those flags. Because it doesn't matter, the green flags all look the same, it doesn't matter which one I pick to place first. But they all look the same. And that's it for today's lecture. Unless you have questions. If you have questions, I'm here to answer them, otherwise. Fuck out, have a great weekend. One of these days, I'm not gonna say it, see whose face looks disappointed. Who does remember, I've forgotten before in a class to say it, someone says, can we get the fuck out? I said, oh yeah. Now we